Hi everyone, my name is Arjun Puri and I am one of the project managers and QA engineers of SPYNdoctors along with my teammates Narjis Pisset, Hernando Salas, and Alex Yonoski. We are the SPYNdoctors and this is the final presentation for CS 6440 Intro to Health Informatics for the fall 2017 semester, and thank you for watching. So our project is called Master Person Index, which aids with deduplication and maintaining consistent ID for its data sources, such as the Death Information System, EDEN. I would like to severely thank our project mentors from the Utah Department of Health, Dr. Clyde Davis and Dr. Jeffrey Duncan. They have been an incredible resource throughout the last several weeks and been there for us every step of the way. This project is concerned with three major parts of Utah Department of Health informatics infrastructure: Epitrax, EDEN, and DOHMPI. Epitrax is a Java web application which serves the need of the specialists in epidemiologists and provides them with access to information on patients' conditions as well as treatments accumulated in several databases on particular infectious diseases. EDEN is the database underlying the Utah statewide death registration system, which, among other things, records cause of death, any type of cause, and comorbid conditions. These pieces of information are in many cases critical for epidemiological research. However, they cannot be accessible to Epitrax users because of incompatibilities of formats and contents of recording personal information in Epitrax and EDEN. Luckily, Utah Informatics Infrastructure includes a special tool called DOHMPI, which stands for Department of Health Master Person Index, which can be used to identify a patient within or across participating systems. Hence, the goal of this project was to provide the web service which would allow Epitrax, acting as a client of the service, to resolve any possible ambiguities in personal patient's data through DOHMPI, and thus link the body of patient information in Epitrax to the detailed death information available from EDEN. The achievement of this goal allows to enhance the functionality of the Epitrax application and to provide Epitrax users additional information critical for research in the epidemiology of various infectious diseases. This is our project requirements input and output slide. According to the requirements, the input fields may include fields shown on this slide. First name, last name, and date of birth are always required. In addition, according to our mentor's requirements, either gender or both address, including street number, and street name are required. The rest of the fields are optional. The output should provide an XML string, the exact contents of which will depend on the outcome of the personal data matching process. At the minimum, it should have one populated field specifying the outcome of the matching. In case of successful match to a person in the DOHMPI, the MPI ID and personal data as they appear in DOHMPI should be populated. If the EDEN record for the matched individual is located as well, then immediate cause of death along with additional causes are populated. In addition, a valid case was not matched in DOHMPI, the row unmatched request table should be generated recording the specified fields for future analysis of matching problems. Based on the above requirement, we suggested the following matching decision logic flowchart. Logic seems a bit complex, but can be summarized in the following way. All required items need to match, and all optional items, with the exception of the phone number, need to match if supplied. Phone number does not need to match even if supplied, but it can be used to narrow down in case of multiple matches. The diagram shows 6 potential outcomes. For example, incorrect input, request not matched, request matched, but no corresponding record in Eden, and finally, the full match in both DOHMPI and Eden. Incorrect input results in the XML string, just informing us about the detected problems in the fields, not match requests, end up adding a row in the unmatched request table. In the case of request match in DOHMPI, XML string with suitably populated fields will be returned. This is our technical implementation slide. The project deliverable represents a RESTful service implemented in the Java application, taking advantage of Jersey technology following the JAX-RS API specification. The service connects DOHMPI, Eden, and potentially unmatched requests databases using the JDBC technology. It achieves performance improvement in case of heavy use of the service by employing connection pooling as implemented in the Apache Tomcat DBCP library. Our web service provides two endpoints, one of which is available for post method and can handle all of the input fields, and another is available for get method and can handle the restricted input of only the required fields, which again are first name, last name, date of birth, and gender. This is a summary of the RESTful API, automatically generated on the basis of JAX-RS compliant code. In order to illustrate the use of the provide service along with the working server-side application, we provided the HTML form, which would allow to test the operation of the web service using the browser as a client. This slide shows the filled-in input form and corresponding output, illustrating the case of matching with DOHMPI personality and the retrieving of the information of the cause of death from Eden. This form uses post method to provide the service. We also provided to our customer the client of our web server implemented as a standalone Java application. This slide shows how the same search looks in the Java client. The source of the Java client, together with the whole set of project files, including the required Java libraries, will be part of the deliverable, which is intended to facilitate the use of the web service by our customers. As far as deployment details go, our application is delivered and deployed in the form of standardized WAR file, which should allow it to use with any Java web container. We tested it with Tomcat, but given the adherence to standards, we anticipate that should work with JBoss, Wildfly, Glassfish, or any other containers as well. Configuration is accomplished through the use of properties files, which would communicate to our application the details of connections to three databases, which are involved in a web service operation. This file can be placed by administrator in any place accessible by running container and specific location on the file. And specific location of the file can be specified using the environment variable. Finally, for our submission for grading using the Georgia Tech tool Docker, our project can be executed for grading in the Docker-oriented environment. The Docker composes of command should spin 4 containers, including 2 databases containing the pre-populated test data. This includes Postgres, MySQL, DOHMPI, and Eden, respectively. The main container running the web service application in Tomcat Engine, as well as the optionally Ubuntu instance where standalone client can be executed. The standalone client access X Windows server from the local host. So if such server is not available, then it can be executed directly on the host using the provided in the project executed jar file. Lastly, this is our Gantt chart. I would like to thank our mentor, Paul, for all the help, and thank you for watching.